Hello, welcome back on our discussion about the OS project. This is the second part which talks about multidimensional arrays in C. Mostly if you have learned C, you will be knowing this arrays and how does the C program handles arrays. This is only an introduction to tell you about how a multidimensional array is stored inside a memory by the C programming language. Now, there are two ways actually a matrix can be stored in a memory. Now, all of us are aware that a memory is a linear byte array, right? Always we talk about byte addressable memory, and the addresses are maybe if I am starting from 0, 1, 2, 3, it goes on, and it's a 8-bit wide or a byte wide memory. So we know that an array, a two-dimensional array, has rows and columns. Now, this is a two-dimensional array of elements. When you have an array of elements which is n rows by m columns, there are n into m elements, and based on the type of the array, maybe you may have a character array, then each element will occupy 1 byte, or you may have an integer array, maybe small letter, then based on the type of the machine, it could be a 32-bit machine, then it could be 32-bit or 4 bytes, or it could be a 64-bit machine where it will be an 8-byte location. And each element will occupy 8 bytes. Now, when I have an array of maybe double, that also will be 8 bytes. So it depends on the type of the array, how many bytes each element occupies. And then another component comes here is whether the elements in the array are stored by what order. Okay, there are two ways this can be stored. Let me explain, which is given as at the top column major and row major. Okay, now let me explain here. Suppose if you have a square matrix like this, the values are here color coded like this. Now this is the array elements stored in the byte array memory. Okay, a memory which is a array of bytes. Each element might occupy 1 byte or 4 bytes or 8 bytes based on the type of element, or it could be a structure, array of structures, then you may have any amount of bytes. Okay, it depends on the size of the structure. So each element is stored followed by another element, but it is in the consecutive addresses. Remember, they need to be in a consecutive address from the program perspective. If you are talking about memory management unit and logical memory and physical memory, what I talk about consecutive bytes of elements does not play a role there, because even consecutive array of elements could be divided into multiple areas if there is a memory management unit and logical memory is mapped to physical memory. That is a separate part of discussion which we will address it during the memory management discussion. Here we are talking about what the program sees. So whatever address you see in a program, that array elements need to be, all the elements have to be together. It's okay, it needs to be together. Suppose if I have an integer array of 3 by 3, then there are 9 elements, and if I assume that an integer takes 4 bytes, then it is 9 into 4 bytes are required to be stored. Now I can decide to store it in this order. Okay, I go row wise and then store one row of elements first, and then the next consecutive addresses I store next row of elements. That I need to be contiguous, so I need to make sure that the adjacent column elements are together, and then the next adjacent row is coming in. I cannot order it in a different way. I need to follow one convention. Either I start storing it from this element. Anyway, I have to start from 0 0. This is the 0 0 allocation. This is the first and 2. Index is always from 0 to 1 2. So always we say that a of row by column. Okay, so you know that row is here 0, 1, 2 and column is 0, 1, 2. So we may store it in this way, whatever is shown here, which is called row major. There is another called column major where I store it column wise. All the column elements are stored in the contiguous memory. So there are two ways I can store the elements. Now, why should there be a definition from the language whether it is going to store it in a row major or a column major? Why can't I just leave it to the implementation of the compiler? It's not possible because you know that C language or any language has to be well defined. There shouldn't be any ambiguity in terms of definition or how a particular thing is handled. So, why is it required? First of all, a language has to be perfect. Cannot have any ambiguity in its definition. This main reason is I may have a compiler from any company which would be compiling a C code and then giving me a library, and then I will be linking it up with my own executable and then running it. Now when two modules compiled by two different compilers, both are C programming anyway, and they are compiling and generating an OBJ for a particular architecture, and then I combine them and then run it together because it is coming as a library, they need to be doing the same understanding. They need to have a common understanding that how an array is stored in the memory. Otherwise, one would assume it is a row major and another one would assume column major, and then these two modules, when they work together, they are not going to be producing the correct result. So, language has to be unambiguous and it has to decide whether it is going to store it in a row major way or a column major way. Now, how does the C language handles? Let us see. It follows row major. Okay, that means it goes and picks up the row elements and puts it in the array in the contiguous locations. And if suppose each element is occupying 8 bytes, it will store them in 8 consecutive bytes, and then the next element of 8 bytes will be stored. And you know that each of the elements should be of the same type. Okay, it can be a structure, array of structures, but still each element needs to be of same type. Here it's not like a list in Python where you can have any other component. Here we need to have a common type of the data which is to be stored in the array. Now, what is the column major? Is there any language which follows column major? Yes, there are some languages. Let me show you the differences of them. Before that, let me see that we have two ways of storing, and the row major address consecutive elements of row elements are stored in the memory. Okay, that I have already explained. And an example here is, suppose if I have two rows and three columns, then they are stored like this. Okay, A11, A12, they come in the contiguous addresses. And if suppose if it is a character array, assume that this is of character type, because I am just saying 0, 1, 2, 3 addresses, so it cannot be occupying more than a byte each element. So it's a character array, which by definition. Okay, so that's it. Now C language follows the row major way of storing the elements. Now, are there any other languages doing it in a different way? Yes. Whereas all this family of languages, C, C++, Pascal and Python follow the row major way. Of course, you know that Python internally, the interpreter is implemented in C++ or C languages. So they have to have a common understanding of how an array is going to be stored. Num array is one of the popular elements there in Python. Now, column major, there is some languages which are following the column major way of storing the arrays. Okay, so you know, you can read about the R languages. Okay, if you are interested to know about what is it, it's about statistics and data analysis. And Julia is another language which is a dynamic programming language designed for a high performance numerical analysis applications. Okay, now what is Python? It's a dynamic programming language where you do not give a type of the variable, and based on what you store in an identifier, the language during the runtime finds out what is the type which is stored in the reference, because there is always references in the identifier, and you find out which object is being referred by that particular identifier. Identifier is nothing but a name of the variable in a Python language. So that's it about 2D arrays, how it is stored. Now just give an example of how do you identify, given an element, okay, how will you identify which address it is? I can give you an address, starting address of the array, because you need to know where the array is starting. So always, if you have an array a of 10, and if you say only mention a, it actually points to the first element, the address of the first element of the array. Now, it's a pointer, of course, but it's not changeable. See, suppose if I have a character pointer, character star CP, I can assign it to maybe to now some value 0x100, and then I use it, and then I may even change it to some other address 0x200. This address, I can assign any address that I want. Of course, it should be the correct address which is within the program's logical memory space, but I can change the address. Whereas once you define an array a of 10, and I say that if I refer a value, that variable of the array element a, it always refers to the same address, because it refers to the same array, and once it is fixed in a particular location somewhere, either local variable or global variable, it is going to have that address forever. Okay, it's not going to be changing, though physical memory in the memory management, that actually where it is stored could be changing, but from the logical memory side, the address is going to be fixed, and the element value a will be always pointing at the address where the array is actually from the logical memory's perspective, and that address is given whenever you are referring to a. You cannot assign any address to the a. Okay, then you are changing the array itself. That is not allowed. Though I am saying a is a pointer array element, if I am passing only the value of the array, or sorry, identifier of the array element, it's actually the pointer or the first address of the first element. But it is different from a character pointer, because this can change the address, we can change the address, whereas that cannot be changed. It is already fixed to some address wherever the program assumes the array is going to be. Now I am saying that I want you to find out where exactly this element is there in the memory, provided I assume that the starting address or the base address of the array is 0. I may give any other value, we can assume any other value, then you have to calculate with respect to the base address. But if a of 0, okay, this is a two-dimensional array, 100 rows and 100 columns are there, and I am saying that the a of 0 is at the address 0. It could be any other address, I can give it. If I assume it is to be 0, where is the element a of 40 and 50 is going to be? How will you find out? First of all, you have to remember that it is a row major. You are lucky that both row and column numbers are same. Suppose if I assume a of 5 and column is maybe 7, then this is the row, okay, this is the column. Now, row major means, let me take this example because I am giving two different values, 5 and 7. Then, because it is a row major, a of 0 is stored first, okay, and then a of 1, because the row element is picked up, each row element, sorry, a particular row, and then all the different columns are picked up. Okay, I need to write it in not this way, sorry, I need to write it in to both the things I need to mention. So let me write it clearly. There are 5 rows, so 0, 1, 2, 3, 4. Indices are only 0 to 4, and several elements are there, 0, 1, 2, 3, 4, 5, 6. That's all, not 7 is not there. So these are the columns. Now row major means this element followed by this element. That means what is the index of this? It is a of 0 and 0. Now which is the next element? A of 0, because I am picking it up from the same row. In the next column, 1. A of 0, 2. Now how long will it go? It will go up to a of 0 and 6, right? 7 elements. So if I am skipping one row and then coming to the next row, I have to keep it in mind what is the type of the variable, if it is an integer or a character, and then how many columns are there in the matrix. So if I have to go to the next row, I should know how many columns are there prior to it, so that I should allocate space for it. That means I have to give that much of address to those elements and then try to find out where this next row is going to start. So since I am interested in now going in from 40-50 means I am going to the 0 to 39, then 40th. This is not 40th row, it is 41st row. I need to go to the 41st row element, and then 50 is the 0 to the 51st column element in that array. Okay, out of 100 and 100. That means I need to comprehend 100 elements have already been given to all the zeros. Another 100 elements are there in the next row up to this 39. That means if I am looking for a 40th element, already there are 40 into 100. 100 is nothing but the column, max column number. In this case, suppose if A of 5 and 7, I am looking for A of, suppose if I am looking for A of 1 and 5, where is it located? I need to comprehend the 0th row. There are 7 elements have been already given the locations, and if it happens to be a character array, then I can multiply 7 into 1, because each character element is going to occupy 1 byte. If it is an integer of 4 byte, then I have to multiply by 4. So I have to comprehend a row already being allotted. For that, I should know how many column elements are there. So always remember, if you need to calculate address of a particular element in an array, you have to, when you are going from one row to the other row, you have to comprehend that all the column elements are already comprehended in your computation. So you need to know what is the maximum number of columns. That means how many number of column elements are there in an array. I am talking about only a 2D array, which will be extended to the 3D array also. So if I am interested in knowing the address of this A of 1 of 5, I have to comprehend 7 elements have already been stored in the previous one, because its column is 7, that number should be known to you. And then I am looking for A of 1, that means the second row. Okay. In that case, if I am into second row, I need to worry about only what is this element. This is the 6th element, because 5 means 0, 1, 2, 3, 4, 5. So 6th element. So I need to give a 6. Based on this number, I need to give how much of offset I need to calculate to find out the exact address of that particular element where it will be in the memory. Now, let me give you a generic equation. If you have understood my explanation, it is very simple now. See, I can use the index value as it is. This is, if suppose if I am interested in knowing the A of I and A of j, when I gave an example of an array, interested in this 5, I need to give the same value, okay, correct? And then I am assuming that m rows are there and n columns are there, okay. It's little not n by m, okay, m rows and n columns, okay. Let us think it that way. In that case, I need to comprehend for every row element that I am calculating, I need to accommodate the space occupied by the number of columns. In my case, it is n. So I is row element and n is the max number of column elements. So that has to be multiplied. Okay. If I am in 1, that means one row element is taken care of. If my I is 5, that means 0 to 4 is already there. That means 5 rows are already taken care of. So need to be taken care of. That means this number, whatever index I am getting, I can directly multiply by the n. N is what? Nothing but n columns are there. And the size, of course, I need to multiply by size. So this element with this takes care of how many rows are there before I come to the row of my interest. And then I need to come to the column element. Up to that, I have to give that offset, comprehend that offset. That is nothing but a j. J is the column element. Again, I have to multiply by that many elements would have already been stored in the memory. So I need to say j into size. That's why the equation is base address, which could be anything. It need not be 0 always. It can be anything. Base address is BA. then followed by I into n, where n is the number of columns, max columns, and I is the row index, and j is the column index. Okay, I of j, a of I of j. Okay, this, if I am interested in knowing the address of that particular element, this is how you calculate. Okay, this is one interesting problem you could expect. And 3D arrays, I'm not going to the details of that. Can you make a guess, if suppose if I have aijk, how will it be structured in the linear address, linear memory array? Okay, because it has to be stored in a linear fashion. Okay, because we have always the byte addressable memory, and the addresses are going on increasing, and I told you that the array elements have to be in a contiguous addresses from the logical memory aspect. Now this is how it is stored. How you take the lower one and form j by k row matrix, j rows and k columns, and then I planes of I. Okay, so you start from this end, construct the this matrix first, and then come to this matrix. Okay, this that many number of planes will be there, and then if you are having one more dimension, you can imagine that it's going to be, the whole thing is going to be repeated. Okay, four-dimensional array. More complex arrays are used in Python than what you see in C programming, but still the understanding is the same, because underneath Python C is there. So this is how it is stored. Okay, I'm not going to find out, if suppose I need to find the address of this, I'm sure you will be able to compute. If you need to know the address of this element, you should know the total space occupied by the entire array, this array. So you should know the value of j, how many number of columns are there, max columns, and then how many rows are there. These, no, j and k, you should have the value. Okay, the max number. Suppose if I am saying x of 5, 10 and 50, suppose, then if I need to find out any element, suppose, where is that in the memory of, from the base address, what is the offset? Now if I need to calculate, I need to have an idea of how much of space is occupied by a plane of elements. Okay, that is a plane is 10 by 5 matrix. That many, there are 5 such planes are there. I may be interested in finding out a third plane some element, or a fourth plane some element, but I need to know the address of the entire plane before even I come to the location of particular plane of interest or element of interest. So the address, the maximum values of these should be known to you to compute any offset of any element. Okay, unless it is a first element, or maybe within this first array, you don't need to know the entire thing. But if you, the column, maximum column number needs to be known, unless you are interested in the element which is in the first row itself. Okay, or this particular j element. But always when you are defining an array, if you are passing an array, which I'll talk about it soon, to a function, how it is handled by showing the program. Okay, this is how a three-dimensional array is stored and how you compute the offset of a particular element. I am not going into the details of how to compute offset of this, which is outside the scope of this discussion. Okay, now we are going to look at the example code, where we will see how to pass a multidimensional array to a function. Now let me take this page to explain you that. Now suppose if I am interested in passing to a function, which I am interested in you doing it, either it could be integer or float or double, because double operations are very costly, floating point operations. So you can consider having an array of double, maybe two-dimensional array, don't go into the three-dimensional array in your project implementation, and then you want to pass an array to a function. How can you do it? I told you that even if it is a two-dimensional array, you don't have to pass the entire array to a function. It's enough if you pass the starting address of the array. But internally, the program is going to compute any particular element. If you are accessing it, the compiler should know how to generate the offset, how to compute the offset. For that, it should know the highermost elements, what is the maximum number of elements in that array. If suppose it is two-dimensional array, it is enough if you give this. If it is a three-dimensional array, it is required that you give the maximum value here and maximum value here. You don't need to give this. It can be left empty. It is okay if you fill it up. Suppose if what I am saying is, suppose you have a 2 by 5 by 7, and if you are passing this array to a function, then you need to mention the 5 and 7 here. But 2, whether you are mentioning it or not is your choice. But one thing you remember, always when you are passing an array to a function, entire array is not copied in the stack. Only the starting address of the array is passed. So when the address is given is by passing by reference. So when the address of the array, the starting address of the array is given, and inside the program you are trying to access a particular element starting from that address, the compiler should be able to generate the code for computing the offset. Then only it can go to the memory and access that particular element. For that, it should know what is the number of maximum columns or maximum these elements are there in the array which you have passed. So that needs to be mentioned. If you leave this empty, two things empty, the compiler is going to give you an error. It's not going to accept it because it will not know how to compute internally inside the program if you are interested in accessing the particular location of the array element, right? It should know these two values for sure. This you may give a, whatever value you give, that can be used for it to find out. But this maximum value needs to be given, because otherwise it will not know how much of space occupied by one plane of elements. In the three-dimensional, you saw one plane occupies jk, right? I is here, jk is here. So j and k are here, I said. So each plane of elements, how much of space it is going to occupy, if you know that only, you can come to the next plane and access a particular element in it. So you have to leave out that much of space when you are traversing through the memory from the starting address. So remember, this is how it is implemented inside a C language, program. So let me just show you a demo of the program, and before we get into the project, what you are supposed to do. So code is there. We will just look at it shortly. What you do, I am just showing you a code with a two-dimensional array, which is enough for this project. You don't need to go to a three-dimensional array, but I encourage you to try it out. Okay. In that case, if you are passing to a function, you have to make sure that you give both the two elements what is the maximum array sizes you are given. Here I have decided to give the same size, which is actually 1000. So 1000 by 1000 elements and of type double. Okay, just to make sure that a lot of processing is happening. So I have declared a double array with a two-dimensional array, and then I have a function to initialize that. Okay, and how am I initializing it? I am passing the starting address of the array. Always I said that when you are passing an array to a function, it is only the address or the base address of the array is passed. Which address? It's a base address, the starting address of the 0th element. Okay, whatever is the 00 element or 000 element, if it is a 3D array, that address is passed. So you need to give the maximum size of each column, whatever is allowed, except the first. You need to give the remaining values of what is the maximum in each of them, because it should be able to compute the offset while accessing the element or storing some value into a particular element in the array. And then I am giving a value to be written into the entire array. Okay, it's a square matrix. Of course, you can see that the sizes of both row and column are same, and I am initializing with the same value. I am passing a float value, but I am having a double array. Is it okay? Yes, because it's a higher dimension. From a lower dimension to higher dimension you are going. Float can be represented in double, not the other way around, right? So float occupies 4 bytes and double occupies 8 bytes. So I am passing a float. It's called in integer. It's called integer promotion. Here we are promoting from float to double, which will be taken care of by the compiler, and float value will be represented in double representation and stored in the array. The same value will be stored. There won't be any loss of precision because the double is not double the size of float. So this is done, and then I am having a data processing function wherein also I am passing an array, and that particular array is just a dummy calculation is done. Each element is multiplied by 2, then 1 is multiplied by 3. I am giving 4.0. Remember, in C, if I have a constant, okay, value, okay, which is not an integer, it is a decimal value, then it's always a double constant. Okay, the constants are always double, represented in double form, because you don't know what you may try to define a pi 22 by 7 in a longer expanded way. So they have given a double representation for those constants which you define. These are all constant values, 2.0, 3.0, or I can give 3.14, whatever. So this double value is multiplied by double, because the array itself is a double, and then it is stored there. So it's just to make some computation, and I am doing it for every element in that. Whatever array I am passing, that entire array of 1000 by 1000 elements are initialized with this value. Not initialized, there's some data processing is done and stored, the value is stored. So now what is the function doing? It is initializing. I am declaring three arrays, and then initializing all of them, then processing them, calling the data processing by passing the array elements. So please remember, I am passing the address of the array, and in each case invocation I am passing different addresses, different array elements, starting address of those arrays, and then the computation is done on that particular array, and then it is printing the value. So now suppose if I compile it and run it, let us see, this is a compilation, and if I run it, I get this value. Just how did I get 9? Because I am initializing 1 for the array 1, then I am passing that to data processing, which is doing 1 into 2 plus 1 into 3 plus 1 into 4, which is nothing but 9. So you are getting a 9 as an output, and I think you can make out how I am getting 18 and 27, because I am initializing the values in the function, initially 2 and 3, and they are multiplied by these constants, and you are getting the result. So why am I showing this? In the project, what I wanted to do is, you have to combine what you have learned from scheduling or fixing the threads to a particular code you learned in the previous demo, and the code is there, and use that code and use this code to combine these two to come up with a project, which is not very difficult. I would say it's trivial, but still you need to understand both of them to actually make these two work. Instead of whatever data processing you want to do, I wanted to do it in a multi-dimensional array. I would be happy if you can do with a 3-dimensional array or even 4-dimensional array, if you are interested in exploring yourself and using it, because that will give you a good flavor of how to use a multi-dimensional array in your program. So how to pass it to a function and make it compute a bigger equation. You can randomly write some equation, or if you are interested or keen to do some mathematical computation, please look into some mathematical code and compute it. But it should be sufficiently long, time consuming, computationally intensive job each thread is doing on different cores, so that you can actually measure the time difference between the processing if all the threads are running on the same core versus all the threads run on three different cores. And that's a demo where you need to write that data processing using multidimensional, preferably, or I would suggest use double only, because that is going to consume more time, because any floating point operations inside the processor, even if it has a dedicated floating point processor, it is going to take few cycles. So that way you can make the thread to run for longer, so that you can find the differences. Why am I stressing on data processing time taking more time? Then only you can identify the difference in the performance when the threads are running on 3 different cores compared to single core. So you need to do some strong processing. I would suggest that you do a multi-dimensional array with the double values. It can be random calculation or any scientific computation if you are interested in. Do that and make it work, and show that when you schedule them on multiple cores, it runs faster compared to schedule them on the same core. If you do that, this is the 10 marks question that is going to be part of evaluation for this course. I hope this video is also useful to you to understand about multidimensional array. This is very important for any systems programmer to know how does C handles multidimensional arrays. Okay, bye bye.